All right, everybody, welcome back to the channel and welcome to today's video. And boy, do I have a good one for us today. I haven't done a whole lot of printing with TPU, and maybe you haven't either, or maybe you have, but I thought it would be cool to go ahead and try to calibrate it in Orca Slicer to see if we could calibrate TPU. The other thing is the TPU filaments aren't accessible through the AMS. You're not supposed to use them in there. I tried once and it does get stuck in there and you do have to take everything apart. So I'll also show how to use the side mount. I printed one of the side mounted deals from Printables, and I'll put the spool on the side here. I went ahead and moved and disconnected the printer from the AMS and moved it out here to the front bench so that we could get a good picture of how to load the filament in there. So I'll show everybody how to load the filament from the side spool, and then we'll get into calibrating. I haven't tried any calibrating. We'll do a test print, and then we'll go through the calibration process and see if it does anything for it. And we'll learn together whether or not you can calibrate TPU or how that process goes. So if all that sounds good, then sit back and relax, and I'll get everything ready. All right, so here's the filament that we'll be using today. It's Polymaker TPU 95. And there's all the information on the side of the box. So let's go ahead and get it loaded. All right, so let's go ahead and get the filament loaded. So the first thing that we'll need to do is remove this, and all you need to do is squeeze on that little blue piece and then pull the tube out just like so. We'll move that out of the way. Then you're going to take your TPU filament, and then we're going to feed it all the way until it reaches the hot end. So let's go ahead and do that. And this is a little finicky because it's not as solid as other filaments, so you really have to kind of line it up in that hole right there. But as you can see, it's pretty easy from there. And I can actually see it in the tube through the glass and everything. All right, so it is in there as far as I can push it. So now let's go to the front screen. All right, so now let's load the filament. So we'll want to go to our settings tab and over to our filament tab. And since I unplugged the AMSs, it's in this mode now with the spool on the side, as you can see. I've already changed this to generic TPU, and I changed the color, and then I hit confirm, and now we'll need to load it. All right, and all we're going to do is load this, and it's going to squirt some through, and we'll need to look in there to make sure that it has purged it out. So we'll go ahead and do that. And I'll fast forward through this part. And now our filament is loaded. All right, so here we are in Orca Slicer. So you'll see that it's still showing my AMS, and if I hit the sync button, it says no AMS filaments. But if I go over to the device page, you'll see that the TPU is loaded. I believe what we need to do here is just concentrate on the first filament right here, and this will be the one that it'll print from. So the first thing that we want to do is go ahead and select the generic TPU, and we're going to go ahead and let it print at this, generic, just whatever the default settings are here. So we'll go ahead and print a Benchy, and then we'll go ahead and start calibrating, and then we'll print a Benchy after that. So let me go ahead and get a Benchy loaded up, and we'll go ahead and do that. All right, so I got the Benchy loaded in here, but we'll see it's showing up as black. I forgot to change the color, but let's go ahead and just save our profile. We won't change any of the settings other than the color. But let's go ahead and change this to orange, hit OK, And then we'll hit the save button here. And what we'll call this is Polymaker TPU calibrated. Even though we don't have it calibrated just yet, we'll go ahead and make this the name. Okay, so go ahead and exit out of there. Not sure why it didn't change the color, but we can change that color there. So now it's showing up orange. Instead of printing this giant Benchy here and taking quite a long time, we'll go ahead and scale this down. And some of you have asked about how to scale things, and it's just this little button right up here. So let's, as long as you keep this uniform scale, no matter which one of these three you change, it'll change it uniformly. Meaning if I change this percentage to something, it'll change the same thing. Same if I change the size, it'll say change it proportionally. So let's do this at 70%. And as you can see, 70, 70, 70, and the size was proportional to that. Let's print it just a little bit smaller so we're not using up so much filament and it doesn't take so much time to do this. So we'll go ahead and slice the plate. And it looks like it's going to take just over an hour to print the Benchy. All right, so we'll go ahead and print the plate, and we'll need to hit flow calibration, and we'll go ahead and hit send, and I'll see you when it gets done. All right, so let's take a look at the Benchy and see how it turned out. All right, so as you can see, lots of errors on here. I don't know if this Benchy is the right thing to print with TPU, but we're going to give it a shot. So we'll go ahead and calibrate everything and see if we can get any of that out. But it is kind of cool that it is a flexible Benchy. So this should be fun. All right, so now that we've done the Benchy, let's go ahead and get started on calibration. So the first thing that I like to do is just hit new project. Don't want to change anything there. Make sure everything's still here. We'll want to go in here and enable flow or pressure advance. Hit save. Back out of that. Okay, first thing that we're going to do is the first pass of the flow rate test. And on this one, it's an hour and 11 minutes. And if we remember from the other one, we shouldn't really expect to see anything past, the -5 and 5, like the 20, the 15, maybe the 10 we would need. So let's go back and prepare, and we can actually take that stuff out. So all I did is clicked on the 20, and I'm going to just hit delete. I can click on that 15, hit delete, -15, -20. So really the only ones that we really need are up to 10. And the only reason that I'm doing 10 on this one is because it had some pretty bad errors. So maybe it is off by a lot. So let's go ahead and do that. And that saved us a good 15, 20 minutes. So I'll go ahead and print this out, and I'll see you when it gets done. And no flow calibration when we print. All right, so let's take our picture test. And somebody had mentioned to put the light to the side and let it kind of rake across, and I think that did help somewhat with these. But like I said before, the ones that are, the 10 and -10, they are really, really off. But if we look at this center one, this is 0, -5, +5. I would say that the 5 looks better. And if you remember, the next test that we're going to do is just going to be in a range of 5. It's not going to be in a range of 20 to -20 like this one was. So always error to the upper number so that the next test will fine tune it back down. So between these two, the 5 looks like the smoothest. So let's go to the wiki and run 5 through the little formula. All right, here's the guide for the flow rate, and we just need to go to this formula. Lucky thing here is 5 is the one that's in here, so we really don't need to do the math, but this is the formula that you need to use, and where this +5 is is the modifier, or what you thought was the smoothest one right here. So we'll use the old flow ratio of 0.98, which I believe is the one that's in here. We'll take a look in a minute, but we should be at 1.029. So let's go to Orca Slicer and make sure that our old flow rate was 0.98, and we'll go ahead and update our filament. All right, so here we are back in Orca Slicer. So let's go into here and see what our old flow ratio was. So our old flow ratio in the TPU is actually at 1. So we do need to do the math again. So all right, so here we are. So basically 1 times whatever this is going to be whatever this is, right? So 105 times 1 is 105, divided by 100 is 1.05. So that's what we'll put in, and we'll run the second test. So here we are, 1.05, and we'll go ahead and save that. We'll back out of there. We'll go ahead and delete everything off of here. Or actually, I always like to do a new project in between these, and don't do the calibration and then go and try to print something. Always do new project afterwards. All right, so now let's go back to calibration and let's run the second pass. And then same thing on this one. I'm not expecting it to be more than 5 out. So we'll go to 6 and delete 9, 8, and 7. So I don't think we'll need to do more than these 5 right here. So we'll go ahead and slice that. And it looks like it's going to take about 45 minutes. So we'll go ahead and print the plate. No flow calibration, and we don't need to do time lapse either. So I'll see you when this gets done. All right, so we're done printing it here, and see we took a picture again. The 4 and the 5 are kind of fuzzy here. They're not relevant here. Really, I think it's between this 2 and the 0 when you look into them pretty close. That one seems to be rougher than this one. And then same thing on this one here. So I really think the -2 looks better. So we'll plug that into the formula and then update the settings in the slicer. All right, so our new modifier is -2. So 100 minus 2 is 98. So 98 times our old flow rate, which was 1.05, equals divided by 100 equals 1.029. Wow, how cool is that? So that's the number that we'll update in the slicer. All right, so here we are in the slicer. Once again, we'll hit new project, discard everything. Then we'll go into here, and 1.029 was what we came up with. So once that's done, we'll just go ahead and hit save, hit O. We want to make sure and hit OK. And then on to the next test. So the next calibration test that we will do will be the pressure advance. So in the pressure advance, we're going to do the tower method. All right, so we'll want to make sure it's direct drive, and we want to do the tower, and we'll go ahead and hit OK. That's going to put this up there, and we'll go ahead and slice it, and I'll see you when it gets done printing. All right, so for the pressure advance test, you're supposed to print this out and then measure up how many millimeters it is until it starts to look bad like it is here, which I say is at 8 millimeters. So they needed to change the pressure advance to 0.016. For mine, you can't really see in the picture here, but it's perfect all the way up and down. So I'm going to leave it at its default. And the default for the pressure advance was 0.02. So we'll leave that alone. And we'll move on to the next test. The next test is going to be the temperature test. So I did notice a lot of stringing and everything on the flow rate test, and part of that problem could be heat. It could be retraction as well. But we'll go ahead and do a temperature test on it. And if you just select the type of filament that you're doing, does match what is on the box for the polymaker as well. Not that it knows the polymaker, but it does know what the range is for TPU. So we'll go ahead and set up this test, and we'll go ahead and get it printed. So let's slice it, and I'll show you some cool stuff in here that you can do. So in this test, it's going to be changing the temperature throughout the print. And as you can see here, you can see the different colors represent the different temperatures and everything that will be printed here. So you can get an idea of what that looks like. So we'll go back to here, and we'll go ahead and print the plate, and I'll see you when it gets done. All right, so I tried running the temperature test with no result, or with not a great result. Like, I don't know if I can do anything with that. But both times it did that, and it failed pretty much in the same spot. And it's like not pushing out filament anymore when it gets to these temperatures up here. So we won't change anything on that. We'll skip that and move on to the retraction test. All right, so let's go back to the instructions for the retraction test. And this is the important part right here. The default values are 0 millimeters for the start retraction length, 2 millimeters for the end retraction length, and 0.1 millimeter for each of the step. So what that means is at the very bottom here, that is 0 millimeters, and it goes 0.1, 0.2, 0.3, 0.4, all the way up to the top till it gets to 2 millimeters. So let's take a look at the result. All right, so as you can see here at the very bottom, everything looks good, and then as it goes up, it starts to really string. So it looks like anywhere from 0, there is one that you can't really see right up there, but maybe up to like 0.3, 0.4. It's only a couple of steps up right there, and after that, it comes back. So let's see what the default value is in Orca Slicer. All right, so where we're going to need to go to change the setting for retraction is you open up the filament thing again and go to setting overrides, and we'll see that retraction is right here. We'll see that the length is at 0.4. So this looked good from 0, and as it went up, it started to get worse. So let's try 0.1 on there. And we'll go ahead and hit save. Okay. Close out of that. Hit new project. We don't want to save. And let's go ahead and see if we made a difference. So we'll go ahead and bring in our Benchy. We'll go back to the scale it to 70, slice it. We didn't do the speed test on this one just because I don't think that thing's gonna do super high speed on there. So we'll leave the speed, the volumetric max speed alone, which you see is set fairly low here. And from everything that I've looked up, it should be pretty low on there. I don't think we want to make it any faster. So let's see if we had any effect on the quality of the print. All right, so before looking at the Benchy, let's go ahead and unload the filament so we can get the AMS reconnected. So we're just going to close out of here, go back to our settings, go back to filament, and then we're going to click unload. And it's basically going to heat the nozzle up, cut the filament, and then we're going to manually pull it back out of the tube and go from there. All right, so all I did was pull the filament back, and we're ready to reconnect the AMS. All right, so let's see if we had a result on the quality of print. The one on the left is the one that we printed first, and the one on the right is what we printed after calibration. Now, I don't know if this Benchy is the best thing to print out of TPU. It did a pretty good job on most of it, but on the overhangs, it seemed to struggle. And you can see it struggled quite a bit on the first one. And you can see all the way into there, it really, really struggled. It's not perfect on here, but it did do a better job. So we did have a result. I won't go through the whole process again on film, but I will go through the process one more time because it did have an effect on there in a positive way. So it's not perfect, but it is getting there. So the answer to the question is, can you tune it or can you calibrate the filament? It looks like you can, and I'm having some success with it. I'm not sure that this is the best thing to print, but this does test gaps, overhangs, arches. It does test everything. That's why I like using this Benchy. But it did have a result. It did have a good result. So I hope this helped everybody. If you've messed around with TPU and have any tips or tricks, please leave them in the comments below. If I did anything wrong or could do anything better, let me know. It's really the first time I've ever printed with TPU, but I did see a positive result with the calibration. So I hope this helped everybody. Have a great week. Hit that like button. Please subscribe. Thank you for all my patrons.